This video is going to look at the localization of function. So if we have a look at your specification, there's key things you've got to know in this area. Localization of brain function, and then 6 different areas or centers of the brain. The motor center, the somatosensory center, the visual, auditory centers, and then 2 language centers within your brain, known as Broca's and Wernicke's areas. So these are 6 different areas of the brain. You've got to know where they are and what the function of them is. So we're going to look at the AO1. So what the role of each of these different centers are, where you can find them. But before we get into what they all do, we want to define what this word localization means. And localization basically refers to the theory that specific areas of the brain are associated with particular functions. So a set area of the brain has a set role. So for example, the motor center of the brain will be in charge of voluntary movements of all your muscles. And there's a key term you've got to know, and this is important throughout all of the different biopsychology videos we look at. And it's the idea that we have 2 different hemispheres of our brain. They're symmetrical halves. We have a left hemisphere and we have a right hemisphere. So we've got these 2 different hemispheres that makes up our brain. And as a general rule, you've got to try and think that the left side of your body is controlled by the right hemisphere, and the right-hand side of your body is controlled by the left hemisphere of your brain. So try and keep that as a general rule. Left side is controlled by your right side of your brain. The right side of your body is controlled by the left side of your brain. And that's really, really important to remember as we go through these different topics in biopsychology. You don't need to copy this down. This is just to show you all the different areas that makes up the brain, all the different roles that happen. So some of the key ones we look here, we've got the motor area of the brain, the sensory area, this frontal lobe, and all of these different parts of the brain, the occipital lobe, they've all got different roles to play. And this is what localization of function is all about. It's looking at each different part of your brain has a different role to play. Now, you do need to know these 4 different lobes. Okay, your brain has these 2 hemispheres, your right hemisphere, your left hemisphere. On top of that, we can divide it into 4 lobes. The frontal lobe, found at the front of the brain. The parietal lobe, found at the top of the brain. The occipital lobe, found at the back of your brain. And the temporal lobe, found at the bottom of the brain. So, we've got the frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. And we're going to try and come up with an anagram in next lesson that links all these words together. So we're looking for FPOT, the front, the top, the back, and the underneath part of your brain. Because you need to know where all the different centers are located, and they're all located in different lobes. So, the key thing, the specification states you need to know these centers. Visual centers, auditory, motor cortex, sensory cortex, and the 2 language centers in the brain, the Broca's and Wernicke's areas. And you've got to know what all of these do. So we're going to start with the motor cortex. And the main function of the motor cortex is voluntary motor movements. So every time you move your arms and you're controlling that, those voluntary movements are all controlled by your motor cortex. And both of our hemispheres, the left hemisphere and the right hemisphere, have a motor cortex. And different parts of the motor cortex will exert control over different parts of your body. So there'll be a part that controls your arms, a part that controls your legs, found in that motor center. And where is it found? It's found in the back of that frontal lobe. So we've got the frontal lobe at the front of your brain here. Towards the back section of that, this is where you're going to find the motor cortex. And if someone did experience damage to this particular area of the brain, they're going to lose control over their fine movements. They might not be able to pick things up as easily or move things around as easily. So fine motor movements will be affected if you experience damage to this part of the brain. The next part of the brain we're going to look at then is the somatosensory cortex. And the main function of this is where our brain deals with sensory information, when we process sensory information. And by sensory information, I mean information that we get from receptors on our skin, things like touch, pressure, heat. We get these sensations, and it's this part of the brain that processes all of this information. And both of our hemispheres have sensory cortexes. So the left side will have one, the right side as well. And this one's now found at the parietal lobe. So the parietal lobe, remember, sits on top of your head here. So it's at the front part of that parietal lobe. So the visual cortex, unsurprisingly, deals with vision. And if you look anywhere, you've got a right side of your visual field and the left side of your visual field. So if I shut my left eye, I can see out of my right visual field over here, my left visual field on this side. And what happens here in this part of the brain is all the information from the right visual field is sent to our left hemisphere. And all the left visual field information is sent to our right hemisphere. Okay? And our left and right visual cortexes. So this part of the brain is now found at the occipital lobe, right at the back of the brain. So our visual cortex is found in the occipital lobe at the back of our brain. And if you get damage to this area, then it's going to affect your visual fields. Okay, so you might experience damage to your right visual field or left visual field, or both of them, depending on the extent of the damage experienced. We've also got the auditory cortex, and again, unsurprisingly, this is dealing with speech-based communication. So anything you hear will be dealt with via your auditory cortex. And this is found in your temporal lobe, so that part at the base or the bottom of the brain. And any damage to this area means that you're going to experience hearing loss. So you're starting to see that each different part of the brain has its own specific function. On top of that, you've got to know two language areas of the brain, Broca's area and Wernicke's area. And we're going to go through what both of these do and how we came to find out that we actually have these two different language areas in our brain. So the first language area we're going to look at is Broca's area. And this was named after Paul Broca, the French neurosurgeon who first discovered it. And he was treating a patient called Tan, who was unable to speak other than saying that one word. He could only say the word Tan. However, he could comprehend everything that you were saying. He understood language, but he could only say one word. So his speech was very, very limited. And what Broca did was he studied 8 other patients who had very similar language deficits. And it all appeared that they had lesions in their left frontal hemisphere. So in that frontal lobe, on the left side, they all had lesions there. So there was some damage to that particular area. And patients that had damage to their right frontal lobe didn't have the same problems. So this led Broca to come up with the idea that there was a language centre in the left frontal lobe of our brain. And that was named then Broca's area, where you weren't able to speak, but you could comprehend language. You could understand language, but you couldn't produce any. And it's this area that is been decided is critical for speech production. So any damage to Broca's area will prevent you from being able to produce speech and language. So the second area we're going to look at is Wernicke's area. This was discovered by a German neurologist called Carl Wernicke. And he discovered that there was not only a part of the brain that was involved in speech, like Broca's area, but there was also a part that was involved in understanding language. And what he found was that this area was particularly found in the left temporal lobe. So remember, the temporal lobe is that lobe at the bottom of the brain. And patients who had lesions in this area could speak absolutely fine, but they were unable to understand language. They couldn't comprehend what people were saying or wouldn't be able to understand speech. And there was a specific region in the left temporal lobe that was responsible for language comprehension. And if that part is damaged, then you develop something called Wernicke's aphasia. And this is where you produce nonsense words as part of your speech. So this particular area is involved with the comprehension or the understanding of language, compared to Broca's area, which is involved in speech production. So we've got these two language areas of our brain. Broca's area here in the left frontal lobe, and we've got Wernicke's area in the left temporal lobe. So two different parts of the brain, both involved in different things. Speech production in Broca's area, and language comprehension and understanding language from Wernicke's area. So, like I said before, the brain is divided into these 4 different lobes. In the frontal lobe, you've got that motor cortex, okay, at the back of the frontal lobe. and that's responsible for all your voluntary motor movements. The temporal lobe at the base of the brain is where we have our auditory cortex, which is responsible for analysing speech-based information. We've got your occipital lobe at the back of your brain, which is important for visual information, and that's where we find our visual cortex. And finally, you've got the parietal lobe, which is important for sensory information. So things such as touch, heat, pressure, that sort of information is all processed in your somatosensory cortex. Okay, so you've got these four parts of your brain, these four lobes, and they all have different cortexes within them. So it's important you know where these parts actually fall. So the motor cortex occurs at this back part of the frontal lobe, the top back part of the frontal lobe. Somatosensory cortex in the parietal lobe at the top. Visual cortex in the occipital lobe at the back of the brain. Then you've got Broca's language area on the left side of the temporal lobe. Lower down, then you'll find the motor cortex. Wernicke's area in the temporal lobe, high up in the temporal lobe there. And you've got the auditory area lower down in the temporal lobe. So you've got to know where these fall within the brain, because you could get a question which asks you which of these cortexes are in which of these areas. So a classic exam question could be this. It might ask you to label what part A is, part B, part C, D, E and F. And you've got to be able to say A is, and name that particular part of the brain. Broca's area. B is the motor cortex. C, what is it? D, what is it? E, what is it? F, what is it? So you've got to know what the different parts of the brain are and where they're found. So now we're going to move on to the AO3, evaluating the localization of function. And one of the major strengths of this is that there is brain scan evidence to support it. There is a wealth of information to support the idea that different neurological functions are localized, that they are controlled by specific areas of the brain, especially when we're talking about concepts such as language and memory. And Peterson in 1988 used brain scans to demonstrate how Wernicke's area was active during a listening task. So people were listening to information, processing that information, and the Wernicke's area was more active in the brain scans. And Broca's area was far more active when people were reading out loud. So remember that Broca's area is in charge of speech production. So there are brain scans to show that different parts of the brain are active when we're doing different tasks. So it suggests that the brain does have a range of different functions. Different parts of the brain must be involved in different actions that we do. So another strength of the localization function is that there is also neurosurgical evidence. By neurosurgical evidence, I mean extreme treatments that are done on healthy brain tissue. So there are two main types of experiments that have been done and operations that are done when we're looking at brain tissue. We've got lobotomies, where we remove parts of someone's brain. We've also got lusotomy, and this is where we cut the connections to a particular area of the brain and hope that it reduces the symptoms. And controversially, it's still used today, especially in some mental disorders such as OCD, where we've got single autonomy. So we cut the connections to a part of the brain called the cingulum, and it stops the anxiety signals being sent to the thalamus. So if you don't have those anxiety signals, you won't get the obsessions, and therefore you don't get OCD. So it is still used today, and the success of these treatments really shows that certain parts of the brain are connected to certain disorders. They are localized. So I'm going to put out quite a bit of information now on Phineas Gage. You can go away and watch a YouTube clip if you think that's going to help you understand this case study more. But don't feel like you have to write every single bit of information on this particular case study down. So, the aim of this case study was to look at a change in Phineas Gage's personality. And Phineas was a man who was working on the railroads. He was 25 years old, and he was preparing to blast a section of rock using explosives. So he was hitting down his tampering iron and dropped it. Hit an explosive on the rock, and his tampering iron, as you can see in the picture, went straight through his cheek up through his brain and took most of his left frontal lobe off. Okay, so you see in the picture, you've got the picture of the tampering iron going through his cheek here, coming up through his head, taking part of his left temporal lobe with it. And the results were that he did survive. He managed to go back to work. He carried on living his life, but there was marked changes in his personality. Originally, he was quoted as being a very calm man, but after the accident, he was seen to be very quick-tempered, angry, rude, and no longer the Phineas Gage he was before. So it shows us that the frontal lobe must have a role for regulating mood. That was the part of the brain that got removed by the tampering iron and had subsequent effects on his personality. So it shows parts of the brain must be involved in regulating certain parts of our behaviour. But again, it's very difficult to generalise these findings. It's only done on one person. It's a very rare case of a very unfortunate individual. So generalising the findings is an issue here. There is, however, an argument against the localisation of function, so a limitation to this particular theory. And this is the notion of brain plasticity, something we're going to learn about a little bit later in our course. And this is when one part of the brain is damaged or has lost a particular function, then other parts of the brain are able to reorganise itself in an attempt to recover and be able to use that function again. So although it doesn't happen every time, there are a lot of case studies of stroke victims who have managed to recover their abilities when they were seemingly lost as a result of having the stroke. So their brain's been damaged in the stroke, they've lost some ability because of their stroke, and their brain's been able to reorganise, rewire itself so that people were able to get back their capabilities.